G'day everyone, welcome to another episode of Python for your Mindstorms kit. Today we're going to learn how to use the color sensor to make your robot follow a line. Hello, my name is Gary, and make sure you are following all these lessons in order. You can check out the previous video here if anything doesn't make sense. Okay, so today we're going to use the color sensor on our robot to follow a line. Line following is one of the really big skill separators between someone who knows a little bit about robotics and someone who knows quite a lot more about robotics. For a lot of school competitions and a lot of contests, it's all about getting your robot to be able to follow a path. And line following today is going to be done in Python, so I hope you can stick around for that. We're going to learn two different types of line following. The first type is going to be simpler, and the second type is called proportional line following. So you're going to get to experience the different types of line following and the principles behind that. Let's have a look at our software. So here, let's go into projects, scroll all the way down, start a new project. Make sure you click on the Python icon and then click create. All right, today we're going to save our project as ca_python_line_following. All right. Whoops. Yeah, I think the screen was a little bit too small for everybody. Just change the size. There we go. That should be better. Okay, line following. How are we going to do this? Well, first make sure that you have Tricky built, and then make sure that you have a black line. So I'm going to use a bit of cardboard like this, but it's best if you have black duct tape. If you have black duct tape, then tape it on the table, and that can be your testing line. Okay, so how does line following work? So this is we're going to go through two different types of line following, like I told you, and because the sensor is on the back of Tricky, we're going to make it move backwards along the line, just so that we get a bit more clarity, and it's also going to be technically better for the robot to travel in the direction of that sensor as well. So how does line following work? Well, remember we've gone through all our different motor functions back in the second episode. So in the second lesson we talked about how there is a move tank block where we can move the different motors individually, or we can have a steer block where we set a steer method where 0 is straight down the middle, and then negative goes towards the left and positive goes towards the right. So here we are using the color sensor. What does the color sensor do? The color sensor is going to detect what color there is underneath it. And if it detects that it is black, we want the robot to steer away from the black line. But then when it sees white, then we want it to steer back towards the black line. So in line following, the fact is that the robot is not following on the black line, but it is actually following on the edge of the blackness of the black line and the whiteness of the table. The table doesn't have to be white. I'll explain how we can compensate for that later. But it's going to work best for this lesson if you have a white background on with a black line. Okay, so let's get this started. So first of all, let's go set our movement motors. Motors equals motor pair A, B. Okay, and then we need our color sensor. So color sensor equals color sensor And where's our color sensor connected to? It's connected to E. Color sensor E. Okay. Let's connect our robot. The Bluetooth button. Okay, all connected. Okay, so we want to make it so that when our robot is moving, okay, here's the thing. We're going to try and make our robot move backwards because of the sensor is on the back side of the robot. So we want this side to be the new front of the robot. So instead of setting the motors to A and B, the new left of the robot is actually on B. So we need to reverse that. We need to set our motor pair to B and A. So let's go back into Mindstorms. Because we want to make our robot move backwards along the line, and we don't want to have to reverse all of our values, we can just set the motor pair as B and A. Alright, here we do a while loop. So this is what we call binary line following. Okay, so while true, we want to go if color sensor dot get color is equal to black, then we're going to go movement motors dot move. Well, actually, it's not going to be move tank. It's going to be start tank because we don't want to tell it how much to move by. So start tank. And then we're going to say 20 on the left motor, 0 on the right motor. So if it sees a black line, it's going to steer towards the right, because 20 is on the left motor and then 0 is on the right motor, so it's going to steer towards the right. But else, if we don't see black, then the movement motors will steer the opposite direction. So 0, 20. Okay, this is called binary line following. So actually, I came up with the term myself. So it means that if it's black, then we steer towards one direction, and then if it's not black, then we steer towards the other direction. And then what you're going to see is that the robot is going to wiggle along on the edge of this black line. Let's try it out. See that? So the robot is now successfully following this black line. All right. Well done. But you see how it is a little bit jerky, right? It's a little bit, it keeps zigzagging. And the reason it's zigzagging is because when it's following the black line, it's either turning one direction or the other direction, and the other motor isn't moving. So if we want to smoothen out the motion, then we can make it so that instead of stopping, then the slower motor is just moving slower than the faster motor. So let's change our values then. So here, let's make it so that instead of staying at 0, we'll move at 10. So that one motor is at 20 and the other motor is at 10. Okay. Let's try that. See, it's much smoother. It's much smoother because it's not as obvious of a stop when it is correcting itself. But it is still sort of wiggling along really slowly. Why don't we just increase the values really, really high? The reason is because the line may change paths, right? If it's really, really straight, then we don't even need to be wiggling at all, right? But sometimes the line might loop around and might change its angle, and that's why we need to make it so that one wheel slows down. If we don't slow down enough, then it's possible that if the line has a very sharp turn in it, then we'll miss that turn, and then it would go off and not follow it. So binary line following also has a weakness where you have a fixed speed for both the wheels, and that is not really good for things like competitions where the line might change quite unpredictably. So here is what we call proportional line following comes in. Proportional line following means that the robot is actually going to detect how much it is off the black line by. If it is off by a lot, then it would steer more towards the line. If it's off by a little, then it doesn't steer as much. And that will give you a much smoother turn and a much smoother line following experience. So let's check out how that works. So we learned how binary line following works. Oops. And now let's look at proportional line following. While true. Now, for proportional line following, instead of detecting if the color is black or not black, we're going to use something called reflected light intensity. And in order to do that, to understand how that works, let's look over here on the top right. You see how there are all of our port readings on the top right. All right, we got A, B, C, and D. A, B, and C are all motors. You can see what their rotation degrees are already. D is our distance sensor, which is detecting a distance and changes when I move my hand in front of it. But then we have E here, which is our color sensor. And you can see it's detecting white at the moment. If I move the robot into the black line, it detects black. See, white, black, white, black. And that's really good for binary line following. If it's black, then we do one thing. If it's anything else, do something else, right? But if we wanted to do proportional line following, we need to change it to reflected light intensity. Reflected light intensity is, instead of detecting the color of what's in front of the color sensor, we are going to detect how much light is bouncing back from this light that is shining down. Okay, so if it is a blackish object, then less light will be reflected. But if it is more of a brighter object, then more light will be reflected. And we're going to use that as a measurement of how much we should be steering. So let's have a look at how we can understand a bit more. So we click on this hub connections button, just like how you would when you are trying to connect. But here you'd see the hardware of all the things that are connected, right? So just making sure that the robot doesn't fall asleep. An E, which is our color sensor, we need to change it from detecting color to reflect. Okay. And now, instead of seeing what color it is, you are now seeing the reflected light intensity. And it's always from 0 to 100%. So if you are over black, so I want you to test it out yourself, okay? So move your color sensor so that it's over the black line. And then here I have 10%. So 10% is what it determines as black. And then move it to the side to where white is. I'm sensing around about 90%, all right? Between 10 and 90%, which is great, okay? So that means that right in the middle is about 50%. So here we make a little note for ourselves. So at 50% reflect, we want the steer value to be 0. Right? Because at 50%, that means that we're right on the edge of the black and the white. And that's when our robot wants to be going completely straight. But then if it strays towards the black or strays towards the white, then we steer away from it. Does that make sense? So here is where the magic happens. So while true, we don't even have to have an if-else block because we're not doing proportional line following. We just say movement motors dot start, and normally if you don't put in any arguments in there, it just moves straight, right? That's because the default value is a steer value of 0. But instead of setting the steer value of 0, I want to make it so that it is the reflected light intensity. So color sensor dot get reflected light minus 50. Okay, so I have 50 because the average of 10 and 90 is 50, but if you have a different value, you'll need to change your value. So mine is 50% because it's right between 10 and 90, but if yours is different, then you're going to need to change that for your robot to work properly. So we're movement motors starting at the color sensors reflected light intensity minus 50. So that at 50, it's going to be 0, but then if it's more or less than 50, then it's going to fix itself up. All right, let's try that. Whoa. That was working, but it was really, really quick. So I better slow down the robot so that you can see clearly how it works. But that worked. That was totally fine. But we need to make sure we go movement motors dot set default speed to say 20, just so that you can see in this short range how it's working. See? Now it's moving buttery smooth, and it doesn't matter if the lines change. It's going to follow the line really, really smoothly. So I'm going to show you how this works on a larger map as well. So you see we encountered a problem. So on that oval, there are two really gentle turns on the long sides of the oval, but on the short sides of the oval, they're very sharp turns. And what happened was that our robot wasn't able to turn fast enough to keep following the line. So in order to solve that, we add something called a multiplier number. A multiplier makes it so that we can follow the sharper turns better, but it also has a trade-off where we don't move as straight. But that's okay. Hopefully, this proportional line following code is going to adapt quite nicely. Let's have a look at how we add a multiplier. So here we go into everything inside motors.start. Put a bracket around all those numbers and then multiply it all by 2. That's the multiplier, and that's all you need to do. That should make it so that it follows the sharper turns better, but if you have a more winding path, then you might have to increase this number even more. But let's have a look at the change and see how it goes. Thanks very much for watching. If you like this lesson and you enjoyed it, then please like and subscribe to my channel. Next lesson, we're going to talk about functions, and I cannot wait. I'll see you next time. Bye-bye.